Now let's look at a few more functions which are available with arrays. So earlier we saw a few operations using some methods available on arrays. Now we will see a few more. The first one which we are going to discuss is flat. So flat is available on arrays with something like array.flat, which creates a new array with all sub-array elements, which means that let's say there is an array in which some of the items are again arrays. So it is sort of an array of arrays, or to be precise, not all elements are arrays. So for example, this is not an array, but some are arrays. So it doesn't matter. What array.flat does is that it takes the elements which are at the first level arrays. And what do I mean by first level, it will be clear very soon. But if there is something like array of arrays or something like that, then what they will do is that it will take all the elements inside that and it will do a flat structure. Rather than array of arrays, it is creating a flat structure. Now I said something like first level. By that I mean that, there can be something like this, that this is an array item, but this is again an array of arrays. So you can see that the whole thing is an array. Its one item is an array which is again having as internal item as again an array. So you can see that here sort of two levels are there. So here the first level elements are arrays, no second level elements are array. Here first level elements are arrays like this, and again some of the second level elements are also arrays. So what you can do is that you can give another argument inside this flat. If you don't provide anything, then by default it will just take 1, means it will consider level 1. So for example, here I have not passed anything, which means that level 1, just flat till level 1, and that's why it has just flattened this and this, and it has not flattened this internal thing. Okay, and that's why it is 1 2 3, and this thing is as it is, and again 6. But if you tell it specifically that do flat till level 2, then it will go to level 2 also. Okay, and again, what if again this thing is again another array? So let's take an example. So let's take the same example. Let's say arr is equal to what was there, 1 2 3 and 4 5 6. So 1 and 2 3 is an is 1 1, and then 2 3 is an array, and then another array with 4 5, and it has element something like this 6. Now if I do something like arr dot flat, now let's say level 1. Okay, firstly let's see what happens to arr. You see that arr is still unchanged. So you have to remember that in some methods it changes the original array, in some methods it does not, right? So in this case, arr.flat is not changing the original array. In fact, it returns a new array. So let's say new array. Okay, and this new array is the thing which we are talking about. Okay, so this new array is the flattened array. So we will remove the original array because that is unchanged. Let's see just the changed array. So original array was something like this. I said something like only array flat. So if I say array.flat 1, then also the same answer. If I simply say array flat, then also it is the same answer. You see, same answer. But if I say array.flat 2, then what it is saying is that, okay, now I am going to second level also, and this 4 5 is also flattened. But again, this 5 can also be an array. Okay, let's say or 5 6 7 something like this, but this is now an array. So till level 2 if I flat, then I get again this thing as an item. Okay, and now you understand fairly clearly that if you do now level 3, okay, then it will be flattened. In fact, if you have to give at least that levels where the flattening is needed. So for example, if you give level 10, till level 10 you flatten, it doesn't matter, there's no level 10. So it knows that till level 3 only it is needed. But if you only provide 2, then less than necessary, then it will not flatten whatever is required. Okay, so now in case of 3 level, it is flattening perfectly. So that is what I wanted to discuss with flat. Now let's see something called every. In array, there is a method called every. It tests whether all elements in the array pass a provided test or not. So let's say there is an array 1 2 3 4, and I want to check whether all the elements are less than 5 or not. Okay, then I can write arr.every and the condition I will write. Okay, and this condition should return true or false, and if this is true for all the elements, then that is what every means, that if this condition is true for every element in the array, then this will return true. And even if at least one, even one of the elements does not satisfy this criteria, then the whole every function method will return false rather than true. Okay, so let's see by an example. So the same thing we'll see, that let's say there is an array 1 2 3 4. Okay, now the thing is that you see that again arr out every is the thing which is returning. So let's say you are doing arr dot every, then you are just taking some items and you are performing some operation on each of the items, but the whole thing is not changed. So if you again you print arr, it is not changed. My whole answer again it is 1 2 3 4, my whole answer is returned as a separate answer, right? So arr let's say some condition, cond means condition, and let's print that condition, then this thing will return true and false based on whether my all the elements satisfy this criteria or not. Okay, what if I say less than 10 and one of the items, let's say this thing is rather than 3, this is 13, then what I'm saying, that is every item less than 10? Is every item less than 10? No, one item is 13, right? And that's why now this will return false. So you understand, whatever condition you write, everything has to be. You can understand something like this, that you could do this manually. Let's say you write your own condition rather than writing this. You could have written your own condition, something like this. That let's say my condition is that arr 0 should be less than 10, and then you repeat the whole thing with and, that and arr 1 should be less than 10, and arr 2, you know, now understand, right? arr 2 should be less than 10, and arr 3 should be less than. So you understand that here you are doing manually all the comparisons, that yeah, so I'm testing whether my arr 0, arr 1, arr 2, arr 3 all, since this is and, which means that every condition has to be satisfied, are all less than 10, and you'll see that it will give you false. But if you do this 3, right, then it will give you true. Okay, so this is what I meant by this thing, but this is complicated, right? This is complicated. So rather than doing this, if you simply do something like this, then very concise way you can represent the same thing programmatically, right? That I will iterate through all the array automatically, every will iterate through all the array, and if something is not working out, it is that condition is not true, then it will return true or false accordingly, right? Okay, next it is not it is not like that you can put any type of condition, just you have to see that it should return truthy or falsy values, right? So let's see that if I return true, okay, then like this condition is true for everything, and that's why it will return again true, right? So any true, let's try to write some hello or some string, right, which is truthy. Now you'll see that again it returns true, which means that internally what it is doing, that it is not forcing you to return some and again if you put empty string, then you see that you will get false, right? So it is not forcing you to return a boolean value like filter, right? Like filter, it is not forcing you to return a boolean value, but you should always try to return a boolean value. But if you don't return, then whatever value you return, it will try to convert, JavaScript will try to convert that value into true or false. So basically if truthy you are returning, then it is treating for that element, that yeah, I'm treating that as true for this element, and false falsy value, then I'm treating false for this element. And what it is doing with that values, it is doing that every means if for every item that thing is I have returned true. This function has returned true for every item. Then only that thing will be the entire thing will return true only when it is true for everything. Let's see some other situation. So let's say I don't want to say it is less than 10, greater than 10, less than 5. Let's say I'm trying to check even numbers. Then what is the condition I should do for even numbers? So every element, if I take the remainder of the element, and if the remainder is 0, then I know that that thing is even. Now this thing is trying to show us that when element is even, then it will return true, and and every function is there, right? Which means that every item should be even, then count will be true. But this is not the case right now, right? So you see that it is false. Okay, so you see that even if you add let's say 6, 8 and remove let's say 3, you see the 2, 4, 6, 8 are all even, but still one is not even, right? And that's why you will see that it will give you false. And again, this one can be anywhere. You see, let's say it is here, doesn't matter. So for every item it is true, then only it will return true, otherwise it will return false. Okay. Okay, so now let's see one thing, that if I remove this one, then you see that it is true. Why it is true? Because now every item in the array is even, and that's why it is returning true. Let's see one more scenario. So earlier we saw something like short circuiting, right? So here we saw that, yeah, if I am doing something like here false, obviously it will be false because not everything is false, but this false is coming from where? So is this that it ran this every is ran for every element? Because in short circuiting we saw that whenever the decision is made, then you don't need to go forward. Okay, then we can explore an experiment here, that whether the same sort of something is happening here or not. Is this thing called for every array item, or whenever the decision is made, like for one the decision is made that it is returning false, then every should return false, right? So why bother going to 6 and 8? But does it do so? In short circuiting, in AND operator or operator, it does so, right? We know. Let's try it out here. So the same thing, I will write a slightly non-implicit return function. So I will properly return this thing, just so that I can check that for what values this thing is called. Let's run it. Now you see that the same sort of short circuiting behavior is here also, right? 2, yeah, it is true, so it is moving forward. 4, yeah, it is true, that's why I'm moving forward. 1, for 1 it is returning false. Now I know that it is returning false, so why should I bother go and run this iterator function, this callback function for 6 and 8? And that's why you see that 6 and 8 is not running. Directly the answer false came. Finally answer came, right? So just this slowly you'll feel that all these sort of things are intuitive, but you can understand that every is sort of a chain of and, and rather than writing chain of and manually, you are programmatically doing like providing is a callback function which tests for a particular condition. Okay. And again, yeah, so let's say here less than 5, and everything is less than 5 except 5. 5 is not less than 5, and that's why it is false, right? One of the examples we saw, right? Sum. Now sum is actually similar to every. The difference is that what every is like chain of ands. Then similarly, sum you can understand like chain of ors. And this you understand that and or both are useful. That's why you can understand that this also might be useful in some scenarios. Tests whether at least one element in the array passes the provided test. Now you can really understand that it is like or. What is or? A or B or C. So in that sense, we see that at least if one of the elements is true or truthy or whatever, then we short circuit and do like that, right? So here also you see that if one of the elements is true, then I see that the whole thing is true. Whole thing is like satisfied, and that's why this thing will return true if at least one of the array, one of the items pass the provided test. Let's see an example. 4, 5, 6, 7. I am testing the condition, is everything less than 5? No, sorry, I'm not saying is some of the items less than 5, because it is sum, right? Is some of the items less than 5? So yeah, 5, 6, 7 are greater than or equal to, but 4 is strictly less than 5, and that's why it will return true, because I know that at least for 4 it has satisfied, right? And again it will short circuit, it will not go and check 5 6 7 this callback function. Again here 5 6 7 8, is there any item which is smaller than 5, strictly smaller than 5? No, there is no item which is smaller than 5, and that's why it is saying that everything is returning false, right? And that's why whole thing is false. Okay, so yeah, now we will see reverse function. So reverse function, what it does is that if you apply the reverse method on an array, then it reverses that array in place. Now what is the meaning of this in place? This in place means that it does not create a new array, it changes the same array without creating a new array, right? So it is not taking extra space. So let's say a million items are here, so it's not that it will create a new array of million items and that is reversed. Okay, it is just that it is not taking extra memory in this array only, it is just like swapping here and there things, and it is trying to make that reversed. And you should understand that this is not reverse sorted, this is just reverse, which means that if you are doing, let me show you, so you can apply on this array also. Okay, so it is just that it was already sorted, and that's why it is like now it looks like reverse sorted, but it just doesn't bother how your elements are ordered, doesn't bother, it just takes and reverses it. So for example, if I apply reverse on here, arr.reverse, right, then you see that, yeah, and then if I print arr, then you see that the whole thing is reversed, right? It was 24168, now it is 86142. So from this side 86142, so it is basically reversed. Okay, now the reverse method also returns the reversed array. Sorry, there is a typo mistake here. So it also returns the reversed array, which means that that if let's say I create, I assign it to a new variable, let's say arr2 or something, then basically if I print arr2, then that is also the same thing. So just like it changes original array also, and that same reference is returned to the and you can test that both are same reference, right? So if you do arr is equal to arr2, then what should you expect? It is returning true, which means that basically the base address, the base reference of both original array and this new array is same. So basically arr.reverse has to return something, right? So what is the most intuitive thing to return? Return the reversed array base reference, right? And that's why it has happened. Okay, sort. Now sort, what it does is that it sorts the elements of the array again in place without creating a new array. So if let's say something like this is there and I do array.sort, right, then it will sort it. So 1 2 3 4 8, you see 1 2 3 4 8, but it will sort the whole. Sort means basically arrange the items in one in some order. Okay, so by default it arranges in ascending order. So there are ways to do it in descending order also, which will come very soon in the few slides, but by default it arranges in ascending order. So so basically arr.reverse, instead of that, if I use arr.sort, and the same thing, you'll see that same thing will happen, that it sorts it and it returns, so you can see here also the sort method returns the sorted array. So it returns and both are same, so no need to print all these things. Just if you print this, then you will see that, yeah, 1 2 4 6 8, 1 2 4 6 8, all the elements are there still, but and the same length will be there obviously, but it is sorted, arranged in ascending order. Okay, now how it is actually internally doing? Internally what is happening is the array elements are converted to strings and then sorted according to each character's Unicode code value, which means that if you have something like this, that let's say I add here let's say whatever 55, right, then if I sort this, then what do you think is going to happen? You see that it has come between 4 and 6, this 5 thing. So actually what is happening is that internally, so I'm just showing you internally what is happening, everything is converted to string. So this 2 is converted to string, 4 is converted to string, 1 is converted to string, 6 is, you are providing number, right? But internally it is converted to string, and then it is sorting, right? And then it is sorting and again printing the whole thing like in the original form. So 2 will be printed as 2, not string 2, right? So but internally it computes the stringified value and then it sorts. Now you see that, yeah, one string should come before two string, before should come four string, and it should come before five. Why? Because five, again, it is string comparison, right? So 4 string is less than 5 because the first character itself, it sees that it is strictly smaller, right? And you can test that by doing something like this. That let's say I do something like I write 5, right? Then you will see that that 5 will come before that 5. So let's remove a few elements. So you'll see clearly that this 5 has come before 55. Why? Because we know that this is only 5. After that, nothing is there. Now this is like a string comparison. You understand, right? So in a string comparison, this 5 will be definitely less than 5, right? Because the first character is matching, then it will see the second character. Here there is nothing, and here there is 5. So nothing is, it will be treated as smaller than something, right? And that's why the order is something like this. Now this is very important because now you can take advantage of it in order to do a lot of things. So if you only are thinking that, yeah, these are numbers, they are comparing numbers and sorting, if you think that internally that is happening, then you might just simply sort numbers or something like that, but you'll not be able to take the full advantage. But if you understand this behavior, that internally how it is happening, then you can take more advantage. So something like this. So let's say I have something like this is 8351AA. Then again, you know that what is going to happen, right? Here I am going to have A and A, capital A. Then if I sort it, let's remove one also for simplicity, and then if you sort it, and I'm not using this variable ARR2, so let's remove it. So if you sort it, then you will see that it is 55568AA. Now how it is, why it is happening, you understand? So basically we are comparing 5 with 55. Obviously it should be smaller, and then 6, 6, 6, 8, and then A. Now we know that this thing is this thing is 16. This Ascii code is Ascii code. So there is Ascii code, and there is here I mentioned something called Unicode, right? So here I mentioned Unicode, right? So basically you can understand that Unicode is a extension of Ascii code. So earlier we saw videos where we saw that Ascii code of capital A is 65, Ascii code of small a is 97, and all that, like that, right? And Ascii code of, and numbers were smaller than 65 also, right? So oh no, I don't I don't remember. I think numbers were bigger than these alphabets, but that was not the point. Here that will not matter because here everything is converted to strings, right? So even if this 5 is there, this 5 thing is internally converted to string. So here we just bother about string character representation, right? And here the 5 character, 6 character, 8 character is coming before this A, which proves the point that definitely this A is what A is, let's say 65, right? And this small a is what, 97, right? And this 8 is coming before this, which means that the character 8 is definitely something less than 65, right? So these things are coming before alphabets, so that can be derived from here. Anyways, that we are not going there. We are just saying that you see what is happening is that internally, as we discussed, that it is alphabetically it is firstly stringified and then compared in a stringified in the string comparison manner, and that's why you see that capital A has come before small a. Even if I have written, and again you do the same thing. So if you write this is small a capital A anywhere, let's say you write here, right? Then again it will come at the end, because I know that all the numbers will be smaller than So 555 is also like 5 number, right? So it will be smaller, and then I will have this 65 code, and then this code, and you can understand that since this is 65, so if I write, let's say, A B C D, doesn't matter, right? Still A B C D will be smaller than A, because at the first character only, this A, capital A, is smaller than small a, right? And that's why it will be like this. So I was discussing that we are always talking about ASCII code, right? But Unicode is also just an extension of ASCII code. So you can understand that ASCII code has simple, like 128 very commonly used characters and a few special characters. So the point is that these are not having complex characters, but Unicode is an extension of newer extension of that, which is standardized by different organizations and followed worldwide, which is having lots of different characters. For example, Chinese characters, Hindi, like Devanagari characters, and emojis. Like there are a lot of things can be here which are having inbuilt support, but they are like backward compatible, which means that whatever ASCII ordering was there in Unicode ordering also, that is same thing is there, right? So if here you write some emoji, then that emoji will also be sorted based on this Unicode. Okay, so yeah, so but if normal things are there, then you can simply see that instead of Unicode, you can simply look up the ASCII table, and that will be sufficient. So this is what I was saying, that yeah, this will be sorted at the place where 5 should be there. Okay, now this is the example which discussed. Okay, yeah, fine. Now let's see a few more examples. So if I do something like this and do sort, then something like this is coming. Okay, so yeah, so why is that? Yeah, so let's see. I am saying that, let's say 5 is there, A is there, and yeah, so let's say I was saying that, yeah, so capital A, small a, uh, and I was saying that, let's say some object is there. Let's say if you sort it, you will get a particular ordering that 555 AA is there, right? Okay, so what is happening? What is happening here? Why this thing is in between, right? So what is happening actually is that, if you understand, if you comment this for some time, and if you simply have some let's say obj, some object, and it can be anything like foo bar or a5, anything, right? And let's print this obj, then I'll get a5, that is fine. But we discussed that there is something called toString method, right? And using this, you can convert any object to its stringified representation, and that stringified representation is not interesting, because it's simply like something like this. Okay, now see what is happening internally. And again, if it is a normal without any keys, then also it is object, right? So here, that is what is happening. So internally, what is happening, that this thing is converted into an array of, like, internally string. So this 5 is converted to 5, right? And this is already, everything is already string, and this thing is again converted to its stringified representation. So you can understand that if I copy paste from here, then it will be something like this. Okay, so internally this thing is sorted. Now you see that if this is sorted, then I am comparing like this a5 with this first character is what? First character is this square bracket, right? Now this square bracket is its ASCII code lies between, like, this capital letters and small letters, right? If you see the ASCII table, and that's why it is lying here. If you want to, like, if you want to get more clarity, then you will clearly understand that if you do something like this, let's say you write particular things. So let's say, and that's what I give example here, that you write something like a square bracket a, right? And square bracket z, right? So let's keep a square bracket z, something like this. Okay, and now if you sort it, then you see that what is happening, you can clearly see that what is happening is that this 555a, and then this thing has come, and then this thing has come, and then this thing has come. So what it proves, the point that you see that square bracket a is smaller than square bracket o is smaller than square bracket z, and that's why this ordering is there. In fact, if you change this small z to capital Z, then what do you expect? You see that it has come before. Why? Because square bracket capital Z is smaller than square bracket a, right? Because this is like what this is like 65 plus 26, right? And this thing is z, capital Z, but this thing is what, this thing is like 97, like, which is smaller than that thing. So this thing will be bigger, and again this thing is like square bracket o. So again, you don't need to go into that detail, but just it is important to know these things, because sometimes if weird answers come, then you should be able to understand that how this sort, simply array dot sort, one liner function, but how it internally works, that if you're comfortable, then it will help you. Okay. Now there is something called compare function. So earlier we saw that, yeah, always it is returning ascending. What if I want descending? What if I don't want ascending, descending? I have some my rule that, you know what, these things should be coming before these things coming. I want to implement my own custom logic, okay, in order to implement this function, in order to implement this sorting. So how do I do that? For that, there is something called compare function. That compare function is passed as an argument of sort. Okay, so if you don't pass anything, then by default, like this is the logic which it is using. But you can give your own logic. You can give your own logic by this passing a function. You understand what is this function? So you can have your own like compare function, whatever, compare function. Understand? And this is we'll just now see that how to create this compare function. But then you can pass this compare function as an argument of this sort, and then now this logic will not happen, right? Now, like whatever data you have, now your logic, whatever you write here, rules, whatever rules you write here, those rules will be followed rather than the internal default JavaScript rules, right, for sorting this. And now you can say that, yeah, by default you are returning me ascending, but I want descending, and that's why you can write those sort of rules here. Now, how to write the rules? The rules is that it takes two arguments. This compare function takes two arguments. So let's say AB, right? Now, what happens is that there are three possibilities, right? Like either I have to place before B, or A have to place after B, or it doesn't matter. Both are equal. These are the only three scenarios, right? For each of them, you have to return some value. So if you return any value which is less than 0, negative value, then basically you are saying that my A should come before B. If you are returning a value from this function which is greater than 1, then you are saying that sort B before A, which means that like A is bigger. Here I am saying that B is bigger. And if you are returning 0, then you are saying that keep the original order, doesn't matter. Okay. So firstly, we are trying to sort something, right? So rather than having already sorted, let's jumble it up. So let's say this is 13, this is 3, and this is 2, this is let's say 4, this is 1, and this is, let's say, 2 here, or whatever. Now, so let's try to return 0, simplest one, right? That is simplest one. So let's return 0 for everything. Now you see that if I was not using this compare function, right, then I print ARR, then it will print a sorted array. And how it is sorting, you see that by default it is sorting by string conversion. And that's why 1 and 1 3 are at one place, and then 1 is smaller than 2, and that's why. So this is not what I want, right? But firstly, see that if I use this my custom logic, then what happens? Okay, so this is interesting. You see, nothing has happened. 413.231 as it is, it has been returned. So why that has happened? Because I'm saying that keep the original order. If you return 0, then it means that A, B is same. Whenever it compares two items, then you are saying that everything is same. A, B, again it compares, let's say, 13 and 3. What happens, you can understand it like that sort function internally calls this compare function multiple times. So basically it tests that, what do you think, this 13 and 3, what should be the order? So internally it will call this thing with 13 and 3, and it will try to see that according to your logic, what are you saying, that whether 13 is bigger or 3 is bigger, what do you want to, how you want to order, right? Bigger in the sense, you understand that whatever you want to come in the right, that has to be that you are saying that it is bigger. So I'm not saying that always the bigger number will be bigger. So let's say I'm trying to 1 2 3 4 5, right? 1 2 3 4 5, I'm trying to order, then I will say that yeah, 2 is smaller than 3, 3 is smaller than 4, whatever. But if I want to order in descending order, 4 3 2 1, then I will say that 2 is bigger in the sense, right? So because I want it to come right, so you just have to signify that thing by giving a returning a value which is negative or positive, and that will say that which has to come before that. So if you don't want to understand it like that, that what is bigger, what is smaller, just try to understand it like what is coming before and what is coming after. So in that sense, that sort logic of compare function is used. Now let's do the interesting part here. So like greater than 0 and less than 0, and try to firstly sort normal ascending thing, right? Because this was by default the sort function is giving the wrong answer, right? Because it is converting to string. From that aspect it is giving correct answer, but I don't want that. I want a proper ordering in terms of numbers, right? So what you can do is that you can say that yeah, if a is less than b, okay, so I'm comparing two things, and I already know that these two are numbers. How do I know these two are numbers? Because I already know that the array on which I am operating is already having numbers, right? If there is some other like some hello or some world or some string is there, then again we have to write here in that logic, you have to handle that, right? But right now we don't need to handle that because we already know that this thing is what, okay. Now if a is less than b, then I know that if something is smaller, I want to ascending, I want to see a is smaller than b. And how do you want to keep? You want to keep smaller things before bigger things, right? And that's why you will return something which is less than 0, because in order to sort a before b, if a and b is passed and you want to sort a before b in the same order, right, then a less than b, then you have to return negative value, right? Which means that in this case you have to return -1. And uh, let's say else if a is greater than b, okay, then I want to flip the situation. Why? Because if a is greater than b, which means that a has to come later, a has to come later, b has to come before, and for that, if you are sorting b before a, then you are saying that you have to return a value which is positive. So you have to return, let's say 1, okay. And else in all other situations, let's say return 0. So all the three situations are handled, right? A less than 0, a greater than b, 0, and if a and b are same, then I know that obviously they are same, and that's why I don't need to do anything positive or negative value. I simply return 0 in order to signify that, right? And you see that when I run this, then now I'm getting the correct sorted order 1 2 3 4 13 as per the mathematical logic, right? Okay, first thing, you don't need to return -1, you can return any negative value, okay. So let's say you return -10, like -10.5 and plus 50, doesn't matter, right? You see that still the order is same. But why to complicate things, right? We have to return some negative value, we have to return some positive value. So in most of the cases where you will see in some documentation or something, they use simple values, right? Negative values, then let's see, return -1, and positive values, any positive value I have to return, then I will just return 1. Okay, this is the standard practice. Okay. Okay, now it sorts, and again, if you can have multiple values, so let's say I have again 3 somewhere, then automatically it will do the thing, and this 1 2 3 3 4 13 is coming, this 3 and this 3 is coming together. Why? Because now that will come in else part, in this final part, and when my sort function will internally call my this compare function with let's say 3 3, then it will see that yeah, this is coming in else part, so it is saying that this 3 and this 3 are basically same, okay. So that is the thing. Okay, that was the second point. Yeah, so let's see some more things. Let's say I want to do descending order. What do you have to do? I simply have to switch this minus 1 to 1 and 1 to minus 1. Because why? So if A is less than B, then I'm returning 1, which means swap the order. Which means 2 is less than 3, then swap the order, which means that it should be something like 3 firstly and then 2. So if you do something like that, then you will see that, see, your now whole thing is reversed, right? So now you can clearly see that how reversed order can be created by your custom logic. Okay. Next thing, can't I simplify this function? So this function is like general way in which you should do that, right? But since these are numbers, actually I can do a trick. Right? And actually that is the trick for which it is saying you negative value and positive value. We'll take advantage of this feature, right? So why they didn't say that no, always return -1 if you want to sort before A before B, and always return +1 if you want to sort B before A. Why they gave us this flexibility, then you can return any negative value and it will be behaving like this, and any positive value and it will be behaving like this. Why they gave us this flexibility? They gave us flexibility because in some scenarios that will be useful to us. Let's see that example. So let's say B is there, right? What if I do something like this, that I simply return A minus B and analyze this situation, that will it behave in a similar manner like these three lines? I simply write A minus B. See what is happening. Now let's say A is 2 and B is 5. Let's say A is 2 and B is 5. With this value it is called. Then A minus B will be what? A minus B will be -3. This will give us -3. And what it says, the logic says that if anything is negative, then I will place the first argument before the second argument. So it will place 2 before 5. And that is exactly what I want, how it should be placed. If I pass 5, 5, then it will be 5 minus 5, 0. And 5 minus 5, 0, and they both are equal. And that's why it will behave like return 0, right? And again, if I pass, let's say, 5, 2, something like that, or 5, 1, right? Then 5 minus A minus B, it is happening, right? 5 minus 1 is what? 4. 5 minus 1 is 4. And what is for 4? Greater than 0, sort B before A. Sort B before A, which means that now it will be swapped. It will be swapped. So something like 1 and 5 will come. And this is exactly what we want, because we want to sort in ascending order, right? And this is what the behavior. So actually, if you run this thing, then you will get the same answer. So rather than writing these 3 lines, you have simply wrote A minus B and it did the work. In fact, if you want to shorten it more, then why to write even that bigger? We know that there is only one return statement, right? Then I can do simply implicit return and comment this out. And if we run this, then we see that we will get the same answer, right? Okay. Now, how do we do this small trick and do descending order? Again, simple. What I can do, then instead of A minus B, I can do B minus A. It will reverse the whole logic, right? If it is 0, then it will return 0. If it is like A minus B and I did B minus A, then my negative will become positive, positive will become negative, and this logic will be flipped, and sort A before B and B before A will be swapped. And now instead of ascending, I will get descending. You see, this descending I am getting. Okay, so so this will work for us. But the problem is that you don't always have this flexibility that in one liner you can do this. You can do something like this when you can perform mathematical operations. But for example, let's say here so here some number or some string is come and you are trying to order that, right? Then you don't know that where to place it, right? Then you have to write your own custom logic and you have to handle those situations, right? What if the situation is that this thing is, let's say, 33 and it should come at proper place. Proper place means let's say instead of B minus A minus B, I am doing something like this. So proper placement, it should be ascending, but now it is not coming ascending, right? It is coming 1 2 3 3 and then it is coming 4 13, because this simple logic has no idea like how to subtract how to subtract string from number or something. So some internally some not a number or something will come, and that will be handled like by default, however JavaScript handles it. But that is not, we have to properly say in our custom logic that this thing, whatever logic you are giving, this thing is wrong, right? This thing is wrong. This 33 should be coming not here but here, if you want that, if we want that whether it is number or a string, whether it is a number in string format or whether it is a number in that format, string format or number format. In both formats I have to use it as a number, right? If you use that, then that can be done, right? Now for this I can do a simple trick, so I'll tell you the trick, but there are more general ways. The most general way is this thing. This will always work, right? So you properly take A, properly take B, and you analyze all the values that what should happen, and you can handle that, like you write your own logic to implement that. But here one simple trick is something like this. See, what happens is that if you have a thing, so let's say const A is equal to let's say 50, right? And you print A and you print, let's say, type of A. Then you see that, yeah, 50 is a string and 50 as a string is printed. But there is a trick. If you put a plus sign, if you put a plus sign instead of in front of a string, which you know that internally that is a number, then you see that it is converted to a number. You see? Now, if this is not a number, so let's say it is hello, then you see what is happening, that it is giving not a number. So again, that will not work. If you already know that something like this is there, then this will help. Now I know in this situation, I know that in this situation, this is the case. I know that in this situation, this is the way. So here I can do that trick that if A is B is a string or number, doesn't matter. What I will do that I will do plus in front of both of them, and then automatically that will be converted to number, because I know that hello or something cannot be there if either there is a proper number or there is a string which is a proper number. If I know that fact, then I can use that logic, right? Yeah. So now you see that this is what is expected, right? This when I did plus A and plus B, which means that now this 3 will be treated as 33. So 33 is biggest among all of them, right? And that's why 33 is at the end, right? Let's say I write something like 11, right? Then it will be treated like number 11, because I am doing this thing, right? And that's why you see that 1 2 3 4 and then 13 and then 11 is coming before 13, because this is treated as number. So now you can understand that you can do this a little bit of tricks and customize the logic. But the main thing is that the whole in general way, this is the, because again we saw that yeah, sometimes it can be something else also, right? And in fact this can be an array of objects, which is the example here given, right? It can, in this case you can see that this is an array of these things, for array of objects, right? Then here you can do some logic, something like that yeah, I am just interested in sorting on the basis of p thing, right? And that's why a dot p minus b dot p, if I do something like that, then it will work out fine and it will give me this answer. It is sorted by p. But if you don't you understand, if you don't provide this callback function, if you simply do arr.sort, then JavaScript has no idea that I don't know, like everything is object, so it will simply treat like square bracket to everything, like by default it has no idea. You have to help JavaScript function to tell that how do you want to sort this, and if you want to sort something like this, then it will happen, right? And again, if you do b.p minus a.p, then again it will be sorted in reverse. Now you have helped JavaScript in order to sort this. And again, same few more examples just for clarity. So let's say p5, p2, p8 or something like this is there. Then you could have done the same thing here, that you see a.p is less than b.p. Earlier we returned properly minus, right? Now let's say properly I know that it might be a string, so a.p, b.p, these are strings, right? But still I have to do, let's say, string wise comparison, right? So string wise comparison means that is string 5 less than 2. is a string 5 greater than 2? So that comparison I'm doing. So if a string wise is less than b string wise, then I'm returning 1. So basically I'm trying to reverse sort, right? I'm swapping that. And similarly, if this is greater, then I'm returning -1 and then 0, which means that it will sort the whole thing based on p value, string wise compared and reversed. And that's why the answer is this thing, right? 8, 5, 2, that is the order of p keys. Okay. And again, you can do a few more things. So for example, b a p p, right? Something like this. So now you'll see that we will see this later in the next set of videos, where we'll see that there is something called two lowercase. So you understand. So let's say there is some const, let's say greet is equal to some hello world, whatever. Now there is something called dot lowercase. So if you have in string functions, it will be discussed in detail, but dot lowercase, right? And if you use this, then you see that now my capital H will become small h, my capital W will become small w. You see that those. So instead of anything, so let's say you have this capital LL, everything will become small. And again, similarly, there is a 2 uppercase, and then that will make everything capital, right? So here what I'm trying to do is that I want to sort this, but if I don't use my own custom logic, then what will happen? It will do something like this, that a and p, it will come bring at first. Why? Because they are like 65 and something which is like less than capital A, less than small a, right? And that's why those capital letters will come first, and then a, b and p will come. I don't want that. I want something like this, that a, whether they are small or big, all a should be first, then all b should be first, then all p should be first, something like that, right? Then I have to write my own custom logic. How can I write that? So simple. Since I have the power of this, my own writing my custom logic, then I will simply say that a, b, I'm trying to compare in this manner. See, I will take one character, and this p is different from this p. This is obvious, right? This is just a variable inside this function. P, I have taken a new variable p, which whatever the first argument is there, I'm making it smaller case. Again the second, I'm making it smaller case. If after making those small, if if that thing first thing is smaller than less than, then I return -1, otherwise greater, which means that the same sorted order, increasing sorted order should be there, but that is on everything made smaller. So now still here you can see that small a is coming before capital A, because in this thing small a is coming before capital A, and here I am saying that return 0. Why? Because if I do small a and capital A both to this thing, a smaller case, then I will go in and this final else part, because those both character codes are now 97, right? And that's why it will come. So you can see that it is coming in proper order, not a and b are coming first. So like this you can write your own logic, and again rather than this you could have done something like this. I'm just giving you different variations. So again, like rather than writing this big, even for strings you could write one small line like this, a dot lowercase, and there is something called char code at. So whatever I'm saying that so a is 65, then how do you know that this thing is 65? So you can have something like char code at, and if you print this, you will see that it is 65. Okay, small a 97. Okay, so whatever the thing, so what I'm trying to do here, and one more thing here, actually you have to pass the index. So for example 0, by default if you don't pass anything, then by default it takes 0, and that's why even if I'm not passing it, why it is useful, because I can have a b c d e f anything, right? Then 0 means that take the 0. This is a string, char code can only be for one character, right? But which character you want to say? So 0. So if you don't pass anything, then also it is 97. If you pass 0, then also only 97. It's just that if you pass something else, so let's say I pass 2, then it is going to the second index 0 1 2 C, and it is giving me character code of C, which is 97 plus 2, right? Okay, so that is fine. So you can use that to directly lowercase and get the char code, and then take the difference, and then again the same answer will come, because now I am taking the char code, which is 85 97 like that numbers, and then I am simply doing that a minus b trick, because a minus b will be negative and a minus b will be positive in that sense, so it will be arranged in ascending order like that. Okay, next there is a fill function, but this video is getting bigger, so I will take that in the next video.